Now this is just the extension of residues. How we are going to evaluate the integral using Cauchy residue theorem. And this is the first one, pole of order 1. This is pole of order n or m. This is pole of order 1. I will discuss what is pole of order n within a minute. Now there are two things. One is residue or the simple pole. Suppose if order is 1, we will see what is order little bit later. So pole of order 1, which is given by this equation. Residue of f of z at z equal to a, which is equal to limit z tends to a, z minus a f of z. Suppose if it is order m, then this equation becomes 1 divided by m minus 1 d to the power factorial, d to the power m minus 1 divided by dz to the power m minus 1, z minus a to the power m f of z. Suppose if m equal to 0 here, you just go with m equals 1. M equals 1. You just substitute m equals 1 here. So 1 divided by 1 minus 1, 0. 0 factorial is 1. D to the power 0 divided by dz to the power 0. Anything to the power 0 is 1. So z minus a to the power 0, that also will become 1. See, you will get the same thing. See, z minus a to the power 1, which is nothing but z minus a. So we will get this. This is for simple pole for order 1. This is for order m. It can be order m equals 2, 3, 4, 5 goes on. Okay. So f of z by Cauchy integral formula, which we learnt in the last video lecture, f of z is given as 1 divided by 2 pi I times integration f of z divided by z minus a dz. So using residue, we will get this. Okay, we will get this. Now let us solve some problem. It's a very simple problem, and we are going to use Cauchy residue theorem to get the answer. So f of z equals 2z divided by z plus 2 z square plus 1. And it has simple poles at z equal to minus 2. See, z plus 2, as usual yesterday I said, z plus 2 equal to 0. So z equal to minus 2. So z equal to minus 2. This is a simple pole because there is no power here. If there is no power, simple pole. Very simple. Z plus 2, which we take z equals minus 2, and this is your simple pole because there is no power here. Suppose if power exists 2, that means order 2. If power is 3, z plus 2 to the power 4, order 4. Simple. Then here z square plus 1. Z square plus 1 equals 0. So z square will be minus 1. So z will be plus or minus I. Is it okay? I repeat, z square plus 1 equals 0. So z square equal to minus 1. Okay, so z will be plus or minus I. So that's why z will have plus I and minus I. Now we will find out residue for the first one. So residue f of z naught or f of a. Okay, f of a is nothing but your minus 2, which is equal to limit z tends to minus 2. You write it z plus 2 first, then you write f of z. I repeat, see here. This is z minus a multiplied by f of z. What is z minus a? It is z plus 2. What is f of z? This is f of z. You substitute in the formula. See here, you just substitute in the formula. This is for the simple pole of order 1. This is for the simple pole, and you substitute z minus a as z plus 2, and this is your f of z. You just cancel these two. Will give you 2z divided by z square plus 1. What is z? Z tends to minus 2. So you substitute for z equals minus 2 here. So that becomes minus 4 divided by, you substitute for z. Z equals minus 2. Substitute for z. So that will give you minus 2 whole square, 4 plus 1, 5. So minus 4 by 5. Is it okay? Now residue f of I. We will go for next one. Residue f of I. So we are going to discuss about z square plus 1 now. So f of I, limit z tends to I. So this becomes z minus I. Z minus I. So this is your f of z. This is your f of z. This is your z minus I. Correct? What is this one? Z minus a. See, z minus a. So this is your z minus I. So z minus I multiplied by your f of z, which is equal to, you have, instead of z you substitute I here. So 2i divided by This one and this one will cancel. Instead of z, you will have to substitute I. So I plus 2. I plus I is nothing but 2i. So 2i written. This 2i will cancel. 1 divided by I plus 2. As usual, in the last video lecture we discussed dividing by a complex number is meaningless. So you have to take the complex conjugate and multiply on both sides. So that will give you 2 minus I divided by 5. I plus 2 multiplied by I plus 2 will be I plus 2 multiplied by minus I plus 2. Is it okay? I plus 2 multiplied by minus I plus 2, that will give you 5. 1 square plus 2 square, 1 plus 4, which is equal to 5. So 5 is here. So minus I plus 2 is nothing but 2 minus 5. 2 minus I. Any doubt? So now we will go for z equals minus I. So z tends to minus I. If f of a becomes minus I. So limit z tends to minus I. So this becomes z plus I. The same f of z. dz divided by z plus 2, z minus I, z plus I. So this term and this term will be cancelled. Z plus 2, z minus I. Instead of z equals minus I, you substitute z equals minus I. So this becomes minus I plus 2. This becomes minus I minus I. So this becomes minus 2i. So you have minus 2i. Both will get cancelled. Minus I plus 2, you have to take the complex conjugate, plus I plus 2. Divided by plus I plus 2. As usual, you will get 5. So plus I plus 2. So 2 plus I divided by 5. Very simple one. So they are all 1 mark questions. Okay. Very, very important questions. You have to find out whether pole of order is 1 or 2. You have to find out first. And second one is you have to find out the residue. 2 things you have to find out. One is the order. Another one is residue. Any doubt? Now I will go for as I said, this is for more than 1. Order is more than 1. So I have written generally. I have written here. Now I will go for the problem 2. Where f of z equals 2z square plus z divided by z plus 2 whole cube. What is the order here? Order is 3. Simple. Immediately you can say. Correct? Your order is 3. Suppose if order is 2, this will become 2. Z plus 2 whole square. If order is 4, z plus 2 to the power 4. So that's all. So we have found out now as the pole of order 3. What if that z equals minus 2? So z plus 2 equals 0. So z will be minus 2. Now use the formula as usual. We'll have to use this formula because order is 3. We'll have to use second formula, not the first one, not of order 1. We'll have to use the second formula which is given as this. So we have 1 divided by m minus 1. M stands for order. 3 minus 1, which is nothing but 2 factorial. And your d squared by dz squared. Here you have z minus z naught, which is nothing but z plus 2 whole cube. Your f of z will be, f of z is given as, this one is f of z, which is nothing but f of z is something, the remaining thing. Now you just take, cancel the similar terms. Stop running. So your analytic function is given as f of z equals 2z square plus z divided by z plus 2 whole cube has a pole of order 3 at z equals minus 2. So we know that the pole of order is 3. And of course we know that z plus 2 equals 0, that will give you z equals minus 2. So you have to use Cauchy residue formula theorem. So residue of f of minus 2 will give you have to use this one. So 1 divided by, where m will be 3. So 3 minus 1, 2. So 1 by 2 factorial. You will have to differentiate 2 times now. So you will have to differentiate 2 times. D squared by dz squared. You substitute m equals 3. So that will give you d squared divided by dz squared. So you have to differentiate. Don't forget. So now your z minus a to the power m, z minus a or z minus z term to the power m, and this will be f of z. F of z is given as this. So similar terms can be cancelled. So you have now 2z square plus z. You will have to differentiate now 2 times. You will have to differentiate 2 times. Now when you differentiate, first time that will give you 4z plus 1. Correct? Just to differentiate with respect to z. 4z plus 1. Again you just differentiate. That will give you 4z plus 1. Answer is 4. 4. So 4 divided by this 2 factorial. So 4 divided by 2 factorial is nothing but 2. 4 by 2 will give you 2. So your residue of f of minus 2 answer is 2. Any doubt? So we'll go for problem 3. Find the residues of f of z. So f of z is given as z plus 2 divided by z minus 2, z plus 1 whole square. Now we have two terms here. This is of order 1, this is of order 2. Very simple one. Very important 1 mark question. Okay, often it will be asked. So this is of order 1 and this is of order 2. So it's a simple pole. So z minus 2 has a pole of order 1, z plus 1 whole square has a pole of order 2. First we will go with simple pole. Z minus 2 which will give you z equals 2, which is a simple pole. Z plus 1 will be z equals minus 1. Okay, so now we will have to use a formula. Same formula, Cauchy residue theorem. So same formula we are going to use. So putting now m equals 1. M equals 1 will give you this formula. This is simple formula. We know already, we learned just now. For putting z equal to 2, we can write this formula as putting z equal to 2. That is z minus 2 equals 0. We will have to write z equals 2. So z equals 2. So this becomes z minus z naught, z minus a. So this must be your z naught. Okay, z naught equals 2 or a equals 2. So this will give you z minus 2 f of z. Instead of f of z, you substitute this one. So we'll have to substitute z plus 2 divided by z minus 2, z plus 1 whole square, and similar term, this term will be cancelled. You have z plus 2 divided by z plus 1 whole square, z tends to 2. You substitute for z as 2. So 2 plus 2 divided by 2 plus 1 whole square will give you 4 by 9. Now we'll go for the second one. Second one is m equals 2. Order is 2. So this equation becomes that equation which you have learned. So second equation becomes order is 2. So this becomes d by ds. D by dz. 1 by m minus 1. 2 minus 1. 1 factorial. 1. So 1. And inside you will have z plus 1 whole square. This is z minus a whole square multiplied by f of z. So similar term will get cancelled. You have z plus 2 divided by z minus 2. So now you will have to differentiate d by dz. Here d by dz, because this is of order, pole of order 2. So we will have to differentiate once. So d by dz. When you are going to differentiate, see, z plus 2 divided by z minus 2, we will have to use only u by v method. The u by v method by v square v du minus u dv. So this becomes, you are going to differentiate z plus 2 divided by z minus 2. So z minus 2 whole square, you keep it as it is, z minus 2. You differentiate the numerator, that will give you 1. Minus, you keep the numerator as it is, you will have to differentiate this, that will give you 1. Simple. Okay, so this is what v du minus u dv by v squared formula goes. Okay, now this term becomes z minus 2 minus z minus 2 divided by z minus 2 whole square. You substitute z equals minus 1. So you will get this z and this z will go off, correct? Minus 2 that will be minus 4 divided by, for z you will have to substitute minus 1. So this becomes minus 1 minus 2 whole square, that will be minus 4 by 9. Sum of residues, that is what the theorem says. You will have to sum all the residues. For 2 poles, 3 poles, there will be 3 residues. So something like that. So you will have to sum all the residues. So 4 by 9 minus 4 by 9, answer is 0. So now we will go for problem 4. Find the residues of f of z divided by z minus 1 whole squared z plus 2. So z minus 1 whole squared has a pole of order. So earlier problem also this is z minus 2 z plus 1 whole squared z plus 2. Similar problem or what? Is it so? This is different. This is z divided by z minus 1 whole squared z plus 2. So what is the order here? 2. What is the order here? 1. So z minus 1 squared has a pole of order 2. So z minus 1 it is given. So this must be z minus 1. 1 is missing. So z minus 1 equals 0. So z equals 1. So z plus 2 has a pole of order 1. So z plus 2 equals 0. So z will be minus 2. Now formula is like this. So we know already formula. Now substitute for m equals 2 here. So m equals 2, that will give you 1 divided by 2 minus 1 factorial d to the power m minus 1, that will be 2 minus 1 divided by dz to the power 2 minus 1. So that will give you d divided by dz. So d divided by dz. This answer will be 1. So z minus a whole square f of z. Okay, as usual, f of z should be replaced by this term. Your z minus a will be replaced by this one. So as I said, z minus 1 whole square multiplied by f of z. F of z is given by this expression. You cancel these two terms out. So that will be z divided by z plus 2. So as usual, we will have to solve this one by u by v method. So you just square this term. So z plus 2 whole square. Keep the term here. You differentiate this. That will be 1. Minus, keep the term that side. You differentiate this with respect to z. That will give you 1. So z plus 2 minus z. Minus z plus z will go off. 2 divided by z plus 2 whole square. What is the limit? Limit is 1. You substitute for z as 1. That will give you minus 2 by 9. Yeah, plus 2 by 9. Okay, any doubt? 2 divided by 1 plus 2 whole square. So 3 square, that will give you 2 by 9. Any doubt? So now we will go for the second one. For m equals 1. Okay, so this is the first one you have finished. We will go for the second one. M equals 1 and z equals minus 2. So m equals 1. M equals 1, the formula goes like this. 1 divided by 1 minus 1 factorial d to the power m minus 1. So 1 minus 1 d to the power 0. So this will have answer as 1 and this will have answer as 1. Z minus a multiplied by f of z. Z minus a is given as z plus 2. Z plus 2 multiplied by your f of z. As usual, z plus 2, this z plus 2 will get cancelled. Z divided by z minus 1 whole square and z tends to minus 2. So wherever you find z, you substitute minus 2. That will give you minus 2 divided by minus 2 minus 1. So minus 3 whole square, that will be minus 2 by 9. So minus, this minus is there. Minus 2 by 9. We'll have to find out sum of the residues of the poles. We have 2 poles are there. So 2 by 9 minus 2 by 9 multiplied by 2 pi I, that will give you 0. So any doubt? Okay, so that's all. So we will stop today. And these problems are very, very important problems in complex numbers. We have used all the techniques from complex integrals, then Cauchy residue theorem, Cauchy-Riemann equation, Cauchy integral formula. Those problems are used to solve very tedious integration problems. Okay, those problems are very important. We can apply anywhere in physics. Thank you, students. We will see in the next class.